Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about the national grid. Okay, so what it actually is the national grid? First of all, let's always consider our homes require electricity. So we've got to get electricity from the power stations to our homes. So we start off with this diagram. We've got a power station on the left and our home on the right. There's a giant cable running from the power station to the home. We know all our devices in the home require a high amount of current, so it should be transmitting high current. But what is the problem if you transmit electricity, all this way, along this wire with a high amount of current? This will result in a large amount of heat loss. This results in a large amount of heat loss. So high current means large amounts of heat loss. Yeah, so the wire is heating up quite a lot. Right, so is that good or bad? Do you want your wires to heat up? Is that useful to us or not? No, it's not. So therefore, this wastes energy and therefore reduces the efficiency. So this is reducing the efficiency. Okay, so this is the problem. If I transmit at high current, I'm getting large amounts of heat loss, therefore reducing the efficiency. So what is the solution? Well, here are the solutions. It's going to be inserting these devices called transformers into the system. So we've got two of them here. This is a first of all, I don't know why that's highlighted. Right, the step-up transformer and a step-down transformer. Don't think of robots, it's definitely not robots. Right, so what is the step-up transformer doing? It's modifying the current. So we'll look at the current for the step-up transformer. High current goes into it, and what's it doing to it? Yep, it's turning it into low current. So let's put that down. So, step-up transformer. The only way it can do that, so high current goes into the step-up transformer, low current comes out. The only way it can do that is by increasing the voltage. In other words, it is stepping up the voltage. So step-up transformer, let's put that down here, step-up transformer. It's going to it will increase the voltage. Have a look, make sure we can see that. Look, so the low voltage goes in, it's now got higher. So it increases the voltage, but as it increases the voltage, the current will drop down. And that's what we want. So it increases the voltage to reduce the current. Yeah, step-up transformer is stepping up the voltage to reduce the current. Why do you want low current? So there's less heat loss. Right. What about the other one? Let's go for the step-down transformer. So we have the other one, step-down transformer. So if I had the step-down transformer, what's it doing? Look carefully. Number one, the voltage goes into the step-down, so the current's going all the way across here. Let me draw some arrows. So everyone's happy, the current's going this way. Yeah, that's where electricity is flowing. So for the step-down transformer, we notice that the high voltage is going in, it's now being dropped down to a lower value here. So step-down transformer will reduce the voltage. It will reduce the voltage, and as it reduces the voltage, what's going to happen is the current goes back up for all our devices to work normally. So it will increase the current. Make sure we get that into our mind. So step-up transformer is going to increase the voltage to drop down the current. Step-down transformer is going to drop down the voltage to increase the current. Now, test your understanding of this whole topic. Test your understanding. Why do we use step-up transformers? Think about the original reason why we need step-up transformers. So the problem at the start was this. If you had high current, it heats up, it wastes energy. So the reason why I had the step-up transformer was to lower the current. we had the step-up transformer to lower the current, therefore less heat loss. So we use step-up transformers to reduce the current, and the reason why to reduce the current to minimize heat loss, minimize heat loss. Okay, yeah, and therefore if you reduce the heat loss, this increases the energy transferred, and therefore this increases the efficiency. Good stuff. Now, summary for this part of the course. So, what exactly is the national grid? It is a system of cables and transformers used to transmit electricity from the power station to your house. So, it's formal definition, put that down. The national grid is a system of cables and transformers used to transmit electricity from power stations to our homes. That's an R there for our homes. Can't spell today. Right, we have the step-up transformer. It will increase the voltage to do what? To reduce the current. Why do you want it to be low current? We want low current through the cables. Why? Because there's less heat loss, therefore increases the efficiency. If you have a step-down transformer, what's it going to do? It's going to decrease the voltage to increase the current once again. And that's it for today's lesson. Give myself a tick, feel good. I shall see you next time for more physics with CeerazzleDazzle. Goodbye.